Okay, this is CP Algebra 1 midterm review video. We are going to be doing packet 1, which was given to you a couple weeks ago, and packet 2, which was given to you earlier, or the end of last week. So let's go through the problems one by one. I'm going to give some hints as we go. I do recommend, if you haven't done a particular problem, that you pause the video, try the problem, and then watch me do it. And when you get to the part that you had gotten stuck or made a mistake on, you can pause it again and then try to finish the problem. Okay, so we're going to do PEMDAS here. Of course, we got to remember PEMDAS. So, and don't forget as I always do, the M and D are on the same level, and so is A and S, of course, right? So PEMDAS really looks like this. So we're going to do parentheses first, and I see that this parentheses is solvable. Sometimes we can't do anything inside the parentheses, like x minus 2. Is a good example of that. If this was x minus 2, it's not, but if it was, we can't simplify that. But if it's two numbers like this, then we can. So 1 minus 2 is negative 1. So watch as I'm going to rewrite everything and not touch anything else except the inside of the parentheses. We can't drop the parentheses. We only drop the parentheses during M and D, right? Only at this stage do we drop parentheses when we do that step. Okay, so the parentheses have to stay so that the 2 is still multiplied by this result. And of course, 1 minus 2 is negative 1. Okay, so the next step we'll do is exponent. There's really only one exponent here. It's squared, and it's not going to really do anything, but it is kind of a trick because a lot of people think that the negative sign is stuck to the 1, but it's not. It's actually negative times 1, right? So the squaring happens first, and then the negative is applied during the multiplication stage. So actually nothing's going to change here because squaring 1 keeps it at 1. And so the most common mistake there is that people write positive 1, but that's not the right answer. Of course, if it had looked like this, right? If it had looked like that and we solve it, yes, then that would be positive 1. But that's not what we have here. So the negative sign is unaffected because that's really during the multiplication stage. Just the 1 is squared. Okay? All right, and then we'll do M and D. Now, during M and D, as soon as we do our multiplication, we drop all the parentheses. So this is not affected. It's not being multiplied except by negative, of course, so it's negative 1. Then this is minus 2 times negative 1, which is positive 2, plus 2. So it's negative 1 plus 4, right? And that's, of course, 3. Okay, let's go to the second problem. All right, this is a substitution problem. So I'm going to take all of these values and substitute them in for the variables. If you remember, we many times in class talked about this. And whenever I'm doing a substitution here or in any future course too, because we do a lot of this, of course, you replace every letter with a parenthesis. So you go character by character, right? Symbol by symbol. So it's a negative symbol, negative symbol. Then when you hit the letter, as soon as you hit the variable, you replace it with 2 parentheses and a blank. Notice the squared stays here outside of the parentheses, and then we just keep writing. We hit another letter. As soon as we hit another letter, we put another set of parentheses. Then we hit plus, then the number 2, then the parentheses, then the 1, it's not a letter, the minus symbol, and then we hit a letter. Now, as I've taught you in class, and I'll color code this, although you can't do that on a test, of course, I'm going to change this to bracket. Why? Because it's inside of parentheses. I just don't want to confuse the two. It's not critically important, but I'm replacing this y here with a bracket. Notice, as soon as I'm done replacing the y, I still have to include this parentheses here, right? That's not part of the y. And a lot of people will forget that and cause problems. Oops, I'm sorry. We hit another variable. My apologies. So, of course, we hit the variable and we replace the x with the parentheses, okay? And of course, you can just look up above to see which which variable is being replaced by which parentheses. So the first one was an x. Of course, x is negative 1. So I'm going to plug negative 1 in. Pick a different color for this. So I'm going to plug in negative 1 for x. There's another x back here at the end, so I'm going to plug a negative 1 in there. This is a z. Z is 1. So I'm going to plug a 1 in here. That's z. And this one inside the bracket was a y. Y is the number 2. Very important to have all these parentheses. Yes, it takes longer, but it's an easy problem. We don't want to lose credit for this problem. Okay, the next step after substitution is to file PEMDAS. Okay. Sorry, I wrote it the wrong way. I didn't want to write it this way. I wanted to write it like this, PEMDAS. And Of course, we have to look inside each parenthesis. So inside this parenthesis, there's nothing I can do to simplify that. There's nothing going on there, just a -1. Can't do anything inside this parenthesis. But this parenthesis is 1 minus 2, so I can do something. And a little tedious, but it's very important to bring everything down untouched until we get to that parenthesis, right? So now it's 1 minus 2 is -1. And nothing I can do about this parenthesis, so P is done, right? Check mark there. Now we're going to do E. There's only one E. It's right here. It's this 2. Everything else doesn't have an exponent, okay? We don't drop parentheses when we do E, right? We drop parentheses during M and D. So we're on E. So we square -1, and that becomes 1. Notice now the -1 is inside the squared. That's why it turns to positive, and we've got this -1 out here. Okay? Everything else stays the same because it's the only exponent in the problem, so we're not going to do anything else. Some of you will try to do multiple steps at a time and potentially get it right, but you have to be really careful, right? Okay, we're on to M and D. Don't forget, during M and D, we drop parentheses. So -1 times 1 is -1. Drop the parentheses. -1, right? You can make a plus negative like we do in middle school. A lot of times we'll do this in middle school. That's okay. You could do that if you want to. In high school, we generally don't do that, but I like to see it, particularly if you've been struggling with negative symbols in the past. But I'm going to just write -1 here. Then this is +2 times -1 is -2. And -1, really, there's always a 1 here, you don't see it, but the -1 times -1 is +1. Okay, and so that's -1, -1, -2, that's -4, plus 1 is -3. And I think that's it for this page. Okay, let's go to the next page. It's problem 3, right? Okay, same thing, we're going to follow PEMDAS again, right? But we're going to work in the numerator and work in the denominator separately, simplify both of them, and then finally do the division, right? Do what we do, fraction divided by fraction probably, okay? All right, so the top of the fraction is actually relatively easy. It's 1/3 times 1/3. Of course, it's negative, right? So -1/3 times -1/3. And you can do the expansion method like we're doing right now in the current unit. You could write 1/3 times -1/3. It's pretty easy. You don't really need to, but it does help reinforce this positive that you're going to get, right? Any even power, everything inside the parentheses is going to be positive. If it's an odd power, it's going to keep the sign that it has, either positive or negative. So in this case, if this was negative, it is negative, and if this was a 3, we'd still end up with a negative answer. But squaring, it's going to make it positive. 1/3 times 1/3. Don't forget, it's numerator times numerator, denominator times denominator. We're not adding, so there's no common denominator, so it's +1/9. Okay, and then down here, we need a common denominator, right? So we'll pull this over. We call this chunking, right? We're going to do this. Break it up. We're going to work just in the denominator. And we need a common denominator. Well, what's another form of 1, right? That has a common denominator of 3. It's 3/3, right? 3/3 is equivalent to 1. I've changed nothing but the form. The value is the same. So 4/3 minus 3/3 is 1/3. And we go back to the problem and we put it here. So what we've done is we've simplified the numerator. We've done all the PEMDAS operations, in this case just exponents, of the numerator. In the denominator, we've done all of our operations, which is just subtraction in this case, with a common denominator. And now we continue and do our division. Okay? And of course, we know that when you have fraction divided by fraction, it's keep, change the division to multiplication, and flip. Okay? And that's 3/9. And that reduces to 1/3. Always remember to reduce your answers. Okay? One note I want to make, sometimes I rush these videos because I don't want to bore you too much, and I go kind of quick. And I do sometimes make mistakes, and you guys have pointed them out, which is great. Obviously, I try to prevent that and avoid it. But if you see something ridiculous, like we go through the whole problem here, and I had a 1/3 here, and I wrote 1/4 or something, or you see, like in the previous problem, I subtracted 2 numbers wrong because I'm rushing. You're smart enough to figure out, like, that's not right. Mr. Campbell made a mistake. Certainly let me know about it, but it shouldn't deter you, and you should be able to figure it out. Many problems, as we know, can be done with photo math on your phone, so feel free to do that to check an answer if you think I did something wrong. And of course, if I figure out something, I'll put a note in the YouTube video in the comments, or I'll send you guys all a message. All right, so it doesn't happen often, but it has happened this year. Do apologize, but be aware that your logic brain can figure it out, right? You can carefully check what I did and notice a mistake, and you'll be able to figure it out. Okay, find the equation of a line perpendicular. That means negative reciprocal slope, right? To the line y equals x. Well, everything is in the y equals mx plus b format, right? Except for vertical lines, which have an x equals some number, right? X equals a number. And of course, y equals a number of horizontal lines, which actually is in this format. It's y equals 0x plus b, right? So you end up getting y equals b, right? Because the m is 0 for a horizontal line. So just don't forget, in general, that's horizontal. This is vertical. And every other line that looks like this is diagonal, right? So we have a diagonal line here. And you can see the slope is 1. It's not written there, but the m, the number in front of the x, the coefficient of the x, is not there, but there's always a 1 in front of the x. And of course, b is 0, right? The y value of the y-intercept is 0 because there's nothing next to it plus 0, okay? So if the slope is 1, then the perpendicular slope is -1. It's 1 over 1, right? Because everything's a fraction. We flip it, which does nothing in this case, and we change the sign. That's what negative reciprocal means, right? Negative, I'm going to abbreviate here. Reciprocal, I'm going to abbreviate. It's in your notes, of course. You can look it up. But if this was 1 over 2, it would be -2 over 1, right? So be careful. But when it's 1, it's easy. The flip doesn't do anything, right? The reciprocal doesn't do anything, but the sign does change. So our new line, right, is y equals negative x, right? -1 slope, plus some b, which we haven't figured out yet. And how do we figure out what b is? We temporarily plug this point in, right? This point is on the line. So we plug it in here and here so that we can see what b is, because this point has to satisfy this equation. So the y value is 3 from this point, -1, 3. The slope is -1, and I'm replacing x. Remember the substitution problem we did earlier? You got to replace with parentheses, plus b. Okay, and this is 3 equals 1. That's a positive, double negative. Negative times negative. 3 equals 1 plus b. Subtract 1 from both sides. 2 equals b. That's not the final answer because they said find the equation. Always important to circle or understand what you're looking for. I'm looking for the equation of a line. So the final answer is y equals our slope. Here it is, -1, right? -1. We don't write the 1 though. And then plus 2 because that's our b. And that's our final answer. Let's write it again. You know, it's okay if you had a 1 here, right? If you put a 1 here, but in your final answer slot, you don't put the 1, that's great. So if it helps you to put 1s in front of variables, that's okay. But just make sure your final answer here does not have a 1 in front of the x, okay? All right, let's go to the next problem. Number 5. Okay, so find the equation of a line perpendicular to y equals 3. Now, we just talked about this. That is a horizontal line. Very important, right? So on an x and y axes, which I like to draw when I do these problems. Whoops, I'm sorry. I meant to get the straight line tool. Okay, so and I love to draw these when I'm doing these problems. Actually, I'll draw it here so we can all kind of see it under the problem. And it's y equals 3, so 1, 2, 3, right? So it's a horizontal line that looks like this. So it's really important to be able to visualize that, right? And then they want a line, I'll pick a different color for this, like blue. They want a line that's perpendicular to that line. Well, every horizontal line, if you ask me for a line perpendicular to a horizontal line, it must be a vertical line. So it could be here, it could be here, it could be here, it could be here, it could even be the y-axis. Any of these lines are perpendicular, right angle, right, opposite direction from the purple line. But I have a specific request, or they have a request, which is it has to go through the point 4, -3, right? So 1, 2, 3, 4, and then this part's less important, -3. I really should do it here, -1, 2, 3. So it has to go through that point right there, right? Get rid of these because they're not really, I was just counting boxes, okay? So it has to be a vertical line because it's perpendicular to the purple line. It has to pass through this point here. So I know it's going to go like this, right? I should have used the tool there, but it's better. Okay, we always want arrows on both ends of a line. Lines go on forever to infinity. So what is the name of this line? We just name it for the x value. All the points along this line have an x value of 4, right? This is 1, 2, 3, and this is 4. So every point on this line has an x value of 4. That's why we name vertical lines with an x equals a number, okay? X equals 4. So it's real easy. We're just really stealing this 4. We know it's perpendicular to a horizontal line, so it's a vertical line, and we know vertical lines look like x equals a number. Find the equation of a line parallel to y equals 3. Okay, so parallel means it's the same direction. So if it's y equals 3, our answer is going to be y equals a number, right? Y equals b, y equals some number. And that number is right here. Okay, I'm going to draw it though because I always tell you to draw these. It's better for you. particularly if you're just learning it. Okay, so the line they want us to draw is, I'll do purple again, is y equals 3, which is actually the same line, right? So it's the same exact thing we have above here. Put the arrows at the end. They're not purple, but that's okay. And then passing through 4, negative 3, the same exact point, so I know it's right about here, right? And this is negative 3. This is what's important. So I'll do blue again, and we want it to be parallel. Okay, but it has to pass through that point, right? So parallel lines are always y equals a number, and that number is negative 3, right? Because that's what it's passing through on the y-axis here. All of the y values, this point, this point, this point, this point, they all have y values of negative 3. So the final answer is y equals negative 3. Okay, number 7, find the equation of a line perpendicular to x equals 3. Okay, well, x equals 3 is a vertical line. So we're obviously looking for a horizontal line, right? Let's make our x and y axes. Let's draw the line x equals 3. 1, 2, 3. Put arrows on the end of it. Okay. Passing to the point 4, negative 3 again. So that, look careful. 1, 2, 3, 4. Negative 3, 1, 2, 3. So right about here. And it has to be perpendicular. Okay, well, perpendicular means it's going the opposite direction, right? So that means it's going to go here and pass through there. Okay, I really should have extended the purple line a little bit more so you can see the perpendicular nature with the right angle there, but that's okay, right? So what's the name of this blue line? Well, it's horizontal, right? It's passing through the point 4, negative 3. So all the y values are negative 3. So it's y equals negative 3. Same answer as above. Okay, find the equation of a line parallel to x equals 3. Parallel. So that means it's going to be x equals something, right? It's going to be x equals a number. Well, that number has to be 4, because if it's going to pass through 4, negative 3, and all the x values are the same, then it has to be x equals 4. You can take the time to draw it like I did up here, if you'd like, and you'll see it working. Okay, and this is a classic. Find the equation of a line passing through the points negative 1, 3, and negative 2, 4, right? Slope-intercept form, that's y equals mx plus b, right? So I need the slope, and the slope is always, and I always like to use parentheses here so I don't make any sign errors, y2. Now, for some reason, a lot of you often, put the x's on the top and the y's on the bottom, but in fact, it's y2, right? And you can label the top here, minus y1. Let me just get a little finer pen here. And x2 minus x1, okay? So y2 minus y1, right? So 4 minus the other y value, and then x2, it's the x value minus the other x value. Okay, very important. We have these parentheses here to help us avoid the potential sign error here. Okay, 4 minus 3 is 1. Negative 2 minus minus 1. So minus minus 1 is plus 1. So it's minus 2 plus 1, which is minus 1. And of course, that simplifies to negative 1. So now we have y equals negative 1x plus b. We had that earlier, if you remember. And I'm going to plug in either point. Students always ask me, which point should I plug in? Doesn't matter. If one of them had a 0, I like to use that one. Or sometimes I like even numbers better than odd numbers. Doesn't really matter. I'm going to use this second point here. And we're going to put the y value in. Parentheses for the x value, very important, or you might mess that sign up, right? I could use parentheses for y, but there's nothing else here, so it doesn't really change anything. And then 4 equals negative 2, that's positive 2 plus b. Subtract 2 from both sides, b equals 2. So our final answer is y equals the slope here, negative x. It's negative 1x, we don't write the negative 1, plus the b we just discovered, which is plus 2. Okay, number 10, find the intersection graphically of the lines. Graphically means we're going to plot both lines, okay? The y-intercept is 6. 1, 2, 3, 4, 5, 6, right at the top of our screen. And then the slope is 2, right? Or 2 over 1. So that usually means up 2 over 1. Now, if I go up 2 over 1, it's off my screen, which is okay. And I could add that point if I wanted to, but it's a little challenging here because I have to go the other direction. So if you want to go the other direction, you can change both of these to negative, because negative 2 divided by negative 1 is the same as 2 over 1, right? Same thing. So I can go down 2, 1, 2, that's down 2, and left 1. Down 2, left 1, down 2, left 1. Okay? And I can use my straight line tool here. So I get a nice line like this. Put arrows at the end, of course, and if you wanted to label it, you could. It's actually not great that we use y and y here. It's probably better to put like y1, y2. We're trying to keep it simple for you, or call this one like h and this one y. So then you could label this. You could say, oh, this is y1. You're welcome to do that yourself to help you. And then y2. Oh, I'm sorry, y2. So I see I made a mistake already and I caught it. So y2. So put a y2 here. See, we did this one first. I don't know why I did that one first. Okay. The second one here, a little tougher because there's actually a 1 in front of the x, right? So the slope is everything but the x. So the slope is all of this. See? Everything except the x. I'll put the x in blue so you can see the x is separate, right? So it's actually -1/2. That's a really confusing one. But the y-intercept's easy. It's -1. So here's the y-intercept. That's where we pass through the y-axis, right? It's actually it's the y value, right? The point is always 0, -1, right? So that's the y value of the y-intercept. This is the y-intercept. Okay? And so we're going to start here, and then the slope is -1/2. There's two ways to write -1/2. Okay? So that way is going to be down 1/2, right? But we could also write 1/-2. Okay? So that means up 1, left 2. Of course, once you get two of these points, you can kind of just see the pattern, if you're careful, and follow the pattern, right? And then I'm going to draw that line. I'm going to change it to be blue. And I'm going to start here and make sure I get as close as I can. Of course, in a test, you can use your ID as a straight edge, which is great, or just be really careful when you're sketching your lines, okay? All right, so it looks like this is a bad problem to do graphically because this point is not going to be where we kind of want it to be, right? Like we'd want it to pass here or pass here, okay? So there's a few things you can do. So on a test, it would actually hit, if this is a non-calculator test, right on the dot, right? But the other way to do it is put it in our graphing calculators. We use the y= key, and we put them both in the calculator, and then we do second calculate, right? And when we do that, it's going to tell us the intersection point. And then the last way we do it is we could use one of our other methods like substitution or elimination and get the fraction and then figure out what this is, right? So there's really no, now they didn't ask us that, so we're just going to kind of eyeball this. On the test, again, we wouldn't have to worry about that. It would actually hit here if we asked you to do it graphically on a test. Unless we said use graphing calculator, then we'd use these methods we've talked about before. All right, so it looks like it's about -1, -2, I would say -2.8. It's just a guess, right? And then it doesn't go up much, maybe 0.3. So maybe we'll do a y value of 0.3, right? And here's 1, here's 2, right? This is -1, this is 1 on the x-axis. So it's not even close to 1, so I'm going to put 0.3. So for this exercise, that's good enough. If we had a graphing calculator, we can get the exact answers. You should try that on your own. And of course, we can use our elimination and or substitution methods and get an exact answer in fraction form. But they didn't ask us to, so that's the best we're going to do. Okay, function notation, right? Excuse me. What does this mean? This means when x is -1, what is f, right? So in other words, if I put a -1 in here, that means I put a -1 in all the t's and we see what happens, right? So f of -1 means what is f, what is the y value, right? When the x value, it's really t in this case, but when the independent variable is -1. All right, well, we just substitute in -1. Don't forget, when we substitute, we always use parentheses, right? So f of -1, the f value when t is -1 is -1 squared, 1. But there's a negative sign in front. I'm kind of doing e and multiplication all at the same time, right? Double negative here, and then there, right? Okay, and then so finally, f of -1 equals 1. There's multiple spaces here. I guess we can put it here. Just I'll make that clear that this belongs here. Okay. Okay. 2f of 0 just means 2 times f of 0, right? So this f of 0 is same operation we did here, right? Except that we're going to replace it with 0, not -1. Now, you can kind of do this one in your head. I don't recommend it, but you know, as we get better at stuff, we should. You know that this is 0. You know that this is 0, so 0 squared times -1, all this is going to be 0, 0, 0, and the only thing left over is 1. So it's not that we're cheating or going too fast, but when we're taking a big test like a midterm exam, it's probably good to use tricks that are relatively easy. They're not going to likely to make a mistake for you. So you just say, okay, it's going to be 2 times f of 0, right? And I'm going to color code that for you, right? 2 times the blue, right? 2 times this. Well, f of 0 means I put a 0 here, I put a 0 here, I put a 0 here, so it's only going to be 1. It's very easy, you can kind of do in your head, right? So it's going to be 1. Okay, because 0 minus negative 0 squared minus 0, all 0 plus 1 is 1. So f of 0 is 1. 2 times f of 0 is 2. So the answer is 2. Okay, these are just 2 separate problems. Subtracted get the answers and subtract them, right? So f of 3 is negative 3 squared minus 3 plus 1, right? And that's, I'm just going to do this quickly. You can take it a little slower if you want. This is going to be 9. That's negative 9 minus 3, negative 12 plus 1 is negative 11. Okay? And then f of 1, we already did. Oh, no, we didn't. I'm sorry, we did f of negative 1. So f of 1 is negative 1 squared minus 1 plus 1, right? So that's just going to be 1, negative 1. So negative 1 is negative 2 plus 1 is negative 1. So finally, we're going to subtract these two. So we're going to take f of 3, right? F of 3 is negative 11. Okay, we're going to take f of 1, which is negative 1. See, these two. And we're going to subtract the 2. Notice my subtraction symbol, right? Okay, so negative 11 minus negative 1. Well, that's a plus 1, so it's negative 10. All right, and finally, f of 2x. So this one's not going to have a numerical answer. We're, like always, whatever's in here, we replace this inside for t, right? F of t. So t has been changed to 2x. So negative symbol, I'm just copying everything down from right here, right? Negative symbol, there's my t, close that, squared, right? I replace the t with the parentheses. Then I have another t, minus, and then another t. Replace that with parentheses, and then plus 1. Okay? And then I'm going to take this, because that's what t was replaced with. It used to be f of t, right? It used to be f of t, but it's not. It's f of 2x. So that means the t's have been replaced with a 2x rather than replaced with a number like we did earlier. Okay? And this is from this lesson, right? We have to expand this. So this is negative times 2x times 2x. I mean, we can use our power rule that we learned too, but like I said, we generally try to avoid the power rule. If it's an easy enough problem like this, we just write it twice. It's much better for us to use our basic rules rather than do an advanced rule. Okay, so this is just negative, so it's 2 times 2, x times x, so negative 4x squared minus 2x plus 1. None of these are like terms, right? That now we're in that was multiplication. Now we're in addition subtraction. None of them are like terms, so the final answer is just exactly what you see. Okay, let's go to the next one. All right, find the intersection, elimination, or sub for these two. Now, whenever there's a variable by itself, like there's two variables by itself, but whenever there's a variable by itself, like y is by itself, we usually use sub. It's just easier. So I'm going to take this equation, and everywhere I see a y, I'm going to replace it with this, right? So y is equal to negative x. So instead of writing a y, right, so I'm rewriting this equation right here, but everywhere there's a y, replace the parentheses. Why? Because y is equal to negative x, so I replace it with a negative x. Okay, so I get negative x equals 2x. A lot of people struggle with this on some of our old quizzes, so this is a great problem for the midterm, right? I'm going to add x to both sides. So what do you get when you add x to both sides? I'm going to have to bring it over here because I'm out of room, right? So I'm going to bring it up here, okay? So what happens when I add x? This is 0. A lot of people don't write anything and then they get confused. Always repeat the equal sign. And then, of course, this is 3x. Then we divide both sides by 3 to get x by itself, which doesn't change anything on the left side, and we get x equals 0. Okay? If x equals 0 and y equals negative x, it's a pretty easy call, right? It's just going to be negative 0, parentheses, of course. So y equals 0 also. So the point of intersection is the origin, 0, 0, 0, 0. And if you were to graph these two lines, you'll see that they meet at the origin. Okay, problem 13, right? We call this literal equations. If you're looking up the unit, literal. I'm going to abbreviate equations, but it's literal equations. And we want to get b by itself, so we want to isolate this. Okay, so we have to kind of do reverse. Oh, I wanted to use the highlighter, sorry. We want to do reverse PEMDAS, right? So I want to get that by itself. So I want to first, I don't want to get rid of this stuff. I want to get rid of this denominator first, right? So I'm going to multiply both sides by 2. So I'm going to multiply this side by 2 and this side by 2. Of course, it's a fraction, so it's going to be 2 over 1. Now, the big mistake that a fair amount of you make is you realize that we multiplied by 2 to get rid of this, and you get rid of this. That's why I don't use the words get rid of this. You get rid of this, and then you go 2a plus 2b plus 2c. You distribute the 2. But that's the whole point, is that division and multiplication undo each other. I don't like to use the word cancel out because it confuses us. They reduce, they undo each other, right? Because it's basically saying, let's do 2 divided by 2, which is 1, and then multiply 1 by everything left over. Of course, multiplying by 1 doesn't change anything. So we get 2x equals a plus b plus c. Okay? Now, because b is having a c added to it, and believe it or not, it's also having an a added to it. Of course, it looks like b is being added to a, but you can think of it as b is hitting here by himself. He's got a plus c and he's got a plus a, right? So I'm going to undo that by subtracting those from both sides. I'll do one at a time. They don't mix because x and a are not the same, so I get 2x minus a equals b plus c. And then, of course, you know, and I should want to make this purple actually, so you can kind of see it. And then, of course, I want to get rid of the c, so I do minus c from both sides. Yes, you could do it both in one step. That would be okay. So the final answer is 2x minus a minus c. Don't try to subtract them. They're not like terms. There's nothing you can do. Literal equations typically have these, you know, crazy big equations. Now, we usually like the variable on the left side, and that symmetric property of equality allows us to just switch sides, right? If it was an inequality, that's not true, but in an equals like this, we can do that. Okay? All right. Solve for x, right? We hate denominators. We always hate denominators. So we want to multiply both sides by the denominator, the common denominator. So I'm going to multiply this side by some number and this side by some number. The common denominator between 2 and 3, those are the only two denominators, is 6, right? That's real middle school, 5th, 6th grade-ish. So I'm going to multiply both sides by the common denominator of 6. And of course, there's fractions, so I do want to multiply by 6. Now, we haven't distributed in a long time, right? And you always try to many of you try to distribute when you're not supposed to. But this is the time to distribute because this is a binomial, right? It's got 2 terms in it. It's got this term here, a minus sign separating the term, and a second term here. So when we multiply outside of a parentheses, right, to a binomial, both terms have to be multiplied together. Now, you can reduce right away, but I'm not going to. I think that confuses you. So I'm not going to do what we did before and reduce because it's not the same exact number. So I'm just going to write 6 over 2 for now, 6x over 2. And I'm going to multiply the negative 1 by 6, right? So that's minus 6. Okay, because 6 over 1 times negative 1 is negative 6. And here I'm going to get 6x, okay, and then plus 24 over 3. Okay, 6 times 4, 1 times 3, right? Numerator times numerator, denominator times denominator, and of course 6x. Okay, so there's a lot of things we can do here, but the obvious thing we want to do is we want to reduce the fractions because then we'll have no more fractions. So if 6 over 2 reduces to 3 over 1, and 24 over 3 reduces to 8 over 1. That makes my life easy because over 1 doesn't mean anything. We can get rid of it. So the final version without fractions is 3x. I'm sorry, see, I made a mistake. 3x minus 6 equals 6x plus 8. Okay, this is 8. All right. And you know what to do. You want to get the x terms together, so I'm going to make minus 3x on both sides. I always like to not have a negative x. It just saves me a lot of hassle, particularly when we're doing inequalities like we did earlier, a couple units ago. So minus 6 equals 3x plus 8. Okay, I'm going to subtract 8 from both sides now. So that's negative 14 equals 3x. And then finally, I'm going to divide both sides by 3. To get x by itself, and it's a weird, I'm using symmetric property of equality to switch sides, of course, right? That goes without saying, but it's x equals negative 14 thirds. That's okay. It's hard to check this, right? So a good check would be to plug this back into the original problem here for these two x's, and you can do it, and it'll work, and you'll be able to check your answer. But when it's a fraction like this, it is kind of difficult to do, and I would recommend only doing that after you've checked all your other work. Okay, solve for x here. So a lot of you want to talk about cross multiplying. That will work here. I'm not a big fan of cross multiplying because it does cause problems. Many of you have experienced it when you try to do it for all kinds of problems, and therefore we don't really teach it. So what we're going to teach is exactly what we did here. We're going to multiply by the common denominator. So x and 32 are not, they don't have common factors because I don't know what x is. So the common denominator is 32x. That's the CD. So the common denominator is 32x. Okay, so I'm going to multiply both sides by 32x. Of course, they're fractions, so I'm going to put them over 1. Okay, and then I'm going to multiply across. So I'm going to get 64 x over x. You know what's going to happen there, I hope. And this is going to be 32 x squared over 32. Now I'm going to reduce, right? So x divided by x, this reduces to 1 over 1. Of course, 32 divided by 32 reduces to 1 over 1. And I'm left to 64 equals x squared, right? And this is a weird problem. We've only done this very rarely, right? But we know the inverse operation. We always talk about that. Like when over here, I wanted to get rid of this plus 8. So the inverse operation is minus 8, right? Subtraction from addition. Here, I had a x times 3. So I wanted to get rid of, right, over here. I want to get rid of the multiplied by 3, so I divided by 3. Now, x squared has, the squaring function has an inverse, and that's square rooting. Okay, that's square rooting. So I'm going to square root both sides of the equation because that's the inverse of squaring. I don't divide by 2 because that's not multiplication, right? And then what happens is I get x equals 8. But really, and even though this is a little advanced for us in Algebra 1, it's actually what we call plus or minus 8. In other words, x equals 8. And x equals negative 8. Okay? Because whenever you square root to solve an equation, when you introduce a square root into a problem, it automatically produces a plus and minus. Okay? So there's actually two answers to this. Probably in the midterm we won't be giving you that. Okay? And you can write plus or minus like that, or you can just write and. It's up to you. Okay? But technically those are the two answers. I would have been thrilled if you had an 8 there, because that means you did all the other work properly. Okay, 16. Common denominator is x, so I'm going to multiply both sides by x, right? We've talked about this. This happens sometimes, right? That's not a letter. I mean, it's not a number, excuse me. Okay, it's not an integer. All right, so that's going to get rid of my denominator. So we're going to multiply x times 6 divided by x. Now, again, you can write 6x over x. Okay, that's typically how I would do it, and then we're going to reduce. But I can also be a little bit smart about it and say, I know I'm going to multiply x by 6, then I'm going to immediately divide by x. So the x's are going to undo each other. In fact, that's why I did it. So you can just go ahead and write 6. And then x over 1 times negative 1 is negative x. I'm not putting it over 1 because I don't want fractions left and I don't need anything over 1 to stay as a fraction. On this side, same thing. So x over 1 times 2 over x. Remember, I'm distributing, if I didn't make that clear before. Binomial, right? So here I'm going to distribute the x over 1. So again, it's 2 times x immediately divided by x. So x over x is 1, so I'm left with a 2. And then 1 times x over 1 is plus x. Okay, and then this is crazy easy. We're just going to add x to both sides. We always want to get our x terms first together. I'm doing the inverse operation of subtraction by adding here. I get 6 equals 2 plus x. And then I'm just going to subtract 2 from both sides. 4 equals x. So something to note here, I don't know if you were following me, you probably, when I wrote this, right? When I wrote this, you probably didn't even need to subtract 2 from both sides. You're like, oh, it's equal to 4, right? So you see how good you can get at something, like almost automatic, when you've done it a million times. Of course, I'm exaggerating when I say a million. When you've done it many, many times, when you've practiced it many times, it becomes very second nature. And so eventually Algebra 1 will come the same. All these skills that we're talking about with you will become the same way. They'll become second nature, but you have to practice them. And the danger that even adults do, right? The danger we all face when we're learning something new is we tend to do it just enough so that we start to get it. And we feel like, yeah, we're getting it. And then we don't practice more than that. And that's when we don't do well, because we haven't practiced enough to be confident and to have it almost be second nature. Okay, solve for x here. There's no fraction to worry about here. I do have two like terms, so I do want to combine those first. So 2x minus x is x. And just leave everything alone. Remember, this is such a good habit to rewrite things we're not using. Okay, now I need to get the x terms together. I see this one's negative, so I want to get rid of that one. So I'm going to, from that side, so I'm going to add 3x, the inverse of subtracting 3x. I'm going to add 3x to both sides. And I'm going to get 4x minus 4 equals plus 2. You don't need the plus, of course, right? The plus is here. I don't want to confuse you, but it's just equal to 2. Okay, and then I'm going to add 4 to both sides. So I get 4x equals 6, and then I'm going to divide both sides by 4. Inverse of multiplying by 4 is to divide by 4. So finally, x equals 6 over 4, which reduces to 3 over 2. Not too tough to check. You can plug 3 over 2 back in here, right? So here's my check. And I love to do checks. We just don't have a lot of time on the video. I'd love you to do them, though. Right, see what I'm doing? I'm just copying down this equation here, but I'm replacing every x with my answer to see if it works, right? Minus parentheses 3 over 2 equals negative 3 times 3 over 2 plus 2. Not the easiest check in the world, but it works. So I just took my answer, I plugged it in for where x is, because that's what I'm claiming that x is equal to, and it should be equivalent, right? I should get like 5 equals 5 or 10 equals 10 or whatever. So 2 times 3 halves, right? That's 2 over 1 times 3 over 2 is 3 minus 4 minus 3 over 2 equals, now this is minus 3 over 1, right? So I get negative 9 halves. So negative 9, 2 times 1 is 2, plus 2. Okay? I'm going to add the 3 halves to this side. It doesn't really matter, but I'm going to add it anyway. So I'm going to add 3 halves to this side. It doesn't matter the order, right? And when I add 3 halves to both sides, right, if I put a plus 3 over 2 here and a plus 3 over 2, I mean, you could just add up those numbers on both sides. You'll get the same thing. All right? So maybe that's easier than this, is a little confusing. But anyway, negative 9 plus 3 is negative 6 over 2 plus 2. 3 minus 4 is negative 1. Of course, we know this is negative 3, right? Negative 3, when you reduce that fraction to 3 over 1. And negative 1 equals negative 3 plus 1. 2 is negative 1. That's a check, and we put a check mark there. So that's a check. Both numbers are equal, okay? That's how we check solve for x problems. Okay, and that's the end of midterm exam packet number 1. I'm going to make a separate video for midterm exam packet number 2.